We're going to be looking at proportional reasoning, and the method we're going to use is a table of values to solve this question. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to solve problems requiring the expression of percent, fractions, and decimals in their equivalent forms. So here's our inquiry type question. We'll read through it once, and the second time we'll highlight important information. There are 270 grade 9 students at a high school dance, and 80% of these students attend the spring dance. Half of the grade 9 students who attend the dance buy their tickets at the door. How many grade 9 students who attend the dance buy their tickets at the door? So this is kind of a two-part question. We'll highlight our part 1 in yellow. There are 270 grade 9 students, and 80% of these students attend the spring dance. Okay, so there's our part 1 of this question. Oh, circle that. And our part 2 says half of the grade 9 students who attend the dance, okay, buy their tickets at the door. So buy tickets at the door. How many grade 9 students who attend the dance buy tickets at the door? So how many buy tickets at the door? And there's our part 2 of this question. So we said we're going to attempt to solve this using a table of values. So maybe that's something you're most comfortable with. So let's set up a table. We're going to need 2 categories. And we'll think of it like this. Number, so this sometimes referred to as a hashtag. This refers to as a symbol of number of students at school. Right? So at really any school in general, that's what this table is going to represent. And number of students attend dance. Okay, pretty big titles what we have here. So let's set this up. Let's say there was really only one student at that school. If there's only one student at that school, and remember, 80% of those students attend this dance, we need to figure out how many of the students would attend the dance. Well, we need to convert our 80%. Okay, so this is our, we'll kind of do it at the, we'll do it at the top here. We have our 80%, okay, and we need to make it an equivalent decimal. So we'll start by turning it into a fraction. I need to take that 80 and divide it by 100, and that's what a fraction is. Okay, and then when I divide 80 by 100, you can use your calculator for this, you'll get 0.8. So this is the percentage, the fraction, and the decimal all linked together. We're going to work specifically with decimals. I feel like that's what you'll probably be most comfortable with, but you could leave it in a fraction form, and it's more than acceptable. Okay, so that would mean 0.8 students would attend the dance at that school, which really doesn't make sense. We don't really have a 0.8 of a person. So let's kind of increase this. Right? Let's go up by the value of 1. Okay, but we increase by 1. Okay, and actually, you know what would be even a greater example of this? Let's slide this down just a little. Let's say there are no students at the school. If there are no students at the school, then nobody would attend the dance. So the increase in the first number is a value of adding 1. Where our increase in the second number is a value of increasing by 0.8. So we increase here by 1, we increase here by 0.8. And if you use your calculator, you'll find out that that's 1.6. Again, if there's 2 students at the school, 1.6 of them attend the dance. It's kind of a funny concept. Now, we know our goal, because our total here is going to be 270. There's 270. Well, if I go up at this rate, this is going to take me forever counting by ones. I literally have to go up 270 times. So I'm going to show us a quick shortcut here. Let's say I wanted to jump to the number 10. Okay, I want to know at the number 10. Well, the reason I decided to figure out how many students would go to a dance if there's only one at a school is we can use this as our base. Okay, our jumping base in our table of values. So let's kind of highlight this. Oh, that's not a great color to highlight with. Let's highlight this. Okay, this will be our jumping base, this specific row here. Okay, and what I can do, if I need to figure out 10, I can use multiplication. I would multiply 1 by the number 10 to figure out, or to jump from 1 to 10. I will do that exact same thing. I'd multiply 0.8 times 10, okay, to figure out what, if there were 10 students at the school, how many attend the dance. And if you multiply 0.8 by 10, you can use your calculator, or you can just move the decimal over 1 spot, and it would turn out 8 students would attend the dance, which makes sense. If there was 10 students at that school, 8 of them would attend the dance. So with that same thing in mind, I'm going to go from 1 to 270. I know that 1 times 270 will get me there. So I need to also do the same thing 0.8 times 270. Okay, and when we do that, we'll bring out our calculator. It might be a bit of a hard calculation to do just off the top of our head, so I just want to fix that. 270 times 0.8 equals 260. So that would mean if there is a school of 270, okay, in our case there's 270 grade 9s, 80% of them attend the dance, that's 216 of them attend the dance. Great, there's our part 1 to the question. Part 2, half of the grade 9 students buy tickets at the door. So we're going to set this up again. Number of students at the dance, number of students, it's our second table, at dance. And then the second part is number who buy tickets at door, buy tickets at the door. Good. So again, we're setting up our table. And we have a very similar type of relationship. Okay. If there are 0 students at the dance, how many of them buy a ticket at the door? Oh, that's none of them. What if 1 student attends the dance? What was our percentage rate? And again, they use the term a half. Okay, so a half can be represented several different ways. A lot of times people see it as 50%. Okay, if I wanted to turn that into a fraction, I would put 50 over 100, and then I would actually divide those two to figure out it as a decimal, which is 0.5. Okay, and again, we're going to work in decimals here. So buy tickets at the door, we'd have 0.5 students would buy tickets at the door. Again, doesn't really make much sense. We wouldn't have 0.5 of a student. But what it's helping us is showing what we're increasing by. If we increase by 1, and if we increase by 1 again and go to 2 students, for our ticket buyers, we're increasing by 0.5. So we increase by 0.5 again. And if 2 students went to the dance, 1 of them would have bought their tickets at the door. Okay, that helps a lot. This time, okay, since we already know the trick, we don't need that third step. We know that there are 216 grade 9 students at this dance. And again, we're going to use our number 1 as our base. It seems to be very helpful as a base term. Okay, so I need to go from 1 to 216. Well, I can multiply by 216. 1 times 216 gives me 216. And whatever I did to my left, I got to do to my right. So I'm going to also multiply this by 216. Okay, to figure out how many students bought tickets at the door. So we take our 0.5 and multiply by our 216 students who are at the dance, and 108 of the grade 9 students would have bought their tickets at the door. And that's what they were really looking for. 108 students bought their tickets at the door. If you'd like to see other ways to solve this question, you can check out our other playlists on proportional reasoning.